Good afternoon. I'm Mary Hall Grant. I'm a member of the board of the Science and Engineering Council of Santa Barbara. Most of you know that in addition to providing these monthly meetings on relevant topics to the science world and to our world period, we support a scholarship through the Santa Barbara Scholarship Foundation that goes to STEM students, and any contributions should go directly to the foundation with STEM or SciEn in the memo line. So people know where the money goes. We also support the science fair in town, and that is going to happen this year after a hiatus. And the last thing I knew, I don't know if they've gotten this up yet, whether we have enough judges. And if not, if you're interested in being a judge, you can contact Devon DeBrock, who's here in the front, and find out how to sign up for that. Board members present are Bill Berenger, Devon, Joseph Strums, and Cheryl Ebner is our secretary. We're happy to have you. On screen is Tim Murphy, and our president. I don't know who else without standing back in the room and looking forward again. So today we're honored to have Professor Trisalyn Nelson talk to us about maps. Dr. Nelson is a member of faculty of UCSB. She has been known in the community as the creator. She led the creation of something called bikemaps.org, a web map geographic information for bicycling and collisions and near misses. He's also interested in ethical use of spatial data and creating data science practices that are inclusive and create a more empathetic world. She has told us that she's sorry she can't be here, but she's not only out of town, she's out of country. She'll be presenting from Canada today. And her recent research focuses on mobility with an emphasis on active transportation and the use of big data and analytics to better plan cities. Late for Boston, New York, Chicago, LA, but what did we say? San Francisco, so I didn't mean to leave that one out. All right. I think we're ready to go. Dr. Nelson, anytime you wish to yes, good. Thank you very much for being with us.
Thank you so much for having me today. At UCSB, I wear a few different hats. I am the Associate Dean of Sciences, which is a super fun job because one of my roles is to look for ways to build more partnerships with our community. So I'm extra glad to be here. I am also director of the Center for Spatial Science, and that is sort of the biggest hat I will wear today as I talk to you about maps that matter. The Spatial Center at UCSB has the vision of collaboratively designing, implementing, and disseminating spatial science for a better world. And at the heart of this is really thinking about how do we develop methods that can improve decision-making and apply those methods to real-world problems while teaching students to be independent thinkers and users of spatial data science. I always explain when people ask, well, I get asked a lot, what is geography? Because people assume it's just the naming of places. And then spatial science is even more confusing. So I always say it is kind of data science where the data that we use is all map-based. So you could think about things like Google Maps as being kind of core to the work that we do. And because so many of the technologies that we have access to, from everything from our phone, our weather apps, our shopping, everything is geolocated. Everything has a GPS coordinate on it. Most big data are actually spatial. They're things that can be mapped. And map data have all kinds of interesting characteristics and ways of visualizing that data that benefit from the perspective of a geographer or really a cartographer. So another way to think about me is as sort of like a digital cartographer. It's another sort of genesis of our field. One of the cool things, in my opinion, about being a spatial scientist at UCSB is UCSB is where the field was coined. So in the 1990s, under the leadership of a professor named Mike Goodchild, he developed really the field and named it Geographical Information Science. So sometimes we use the word geography or geographical, and sometimes we use the word spatial. It's sort of the same. But if you've ever used a GIS or heard of a GIS, it was really at UCSB where that field as a scientific field was developed. So we're going to talk about 4 different projects today that we're working on at the Spatial Center, which really center maps in helping us understand the world or disseminate knowledge of the world to different places. And so you maybe if you see me around sometimes in the Independent, sometimes I love talking about bikes and spatial data, so really any chance I get. So you may have seen me talk about this before. I'm going to talk about a new project we're doing, building a digital twin of nature at the old Bixby Ranch at Point Conception. And then we'll talk about a mapping curriculum project that we're doing, and I'll introduce you to a new service that we're providing at UCSB to give spatial services to more broadly to the community. So the first 2, just so in case you're tracking the time here, the first 2 topics are the bulk of what I'll talk about today, and the last 2 will go quite quickly. But Santa Barbara is a great place to bike, and we have a strong kind of legacy of biking. We have the perfect weather for it, and kind of a pro bike culture that has developed over time. And I really am someone who does not like being in my car. And I actually thought I was the only person that felt this way, that just felt sort of cranky when I had to spend too much time driving. And over time, I realized that there's a whole science behind the mental and physical benefits and social benefits of getting more people on bikes. So there's a physical activity benefit, there's an environment benefit to people are switching from cars to bikes, but it also, biking more builds strong communities. When I arrived to Santa Barbara, I wanted to know things like where is the best biking, where's the best infrastructure, and also what are the trends in terms of riding here? Are we seeing more ridership, less ridership? And it turns out we didn't have any of the data to answer this question. And so I'm going to talk a bit about 3 areas that I would say are kind of deficits in data and and this is not, Santa Barbara is not unique in this. I think most places don't have really great bike data, but we have been working at the Spatial Center to fill gaps in data around bike ridership and volume, around bike safety, and also bike infrastructure. So I'm just going to talk a little bit about what we've done in each of these categories and what we've learned so far. So first of all, one of the questions that people ask all the time is, how did COVID affect biking? Are people biking more now than before, or are they biking less? And this matters just in terms of understanding what's happening in our city, but it also matters because, as we'll talk about in a bit, we're seeing an increase in crash rates associated with biking everywhere, but particularly in Santa Barbara County. And that is, in order to understand what that means, you also need to understand, are we seeing more biking and more crashes? So is the crash rate the same? Or are we just seeing the same amount of biking, but things are getting less safe? What does this mean? So there's a lot of reasons why we need to understand how many people are riding. You wouldn't try to manage a city without understanding what was happening with car volume. And I would argue that bicyclists and pedestrians are some of our most vulnerable road users, and we need to understand what's happening for them as well. So we have been doing a few different projects. One is, you may have seen around town, we get students to go out and count the number of bicyclists that go by a particular location. And the reason we do these manual counts is because It is the only way we can differentiate e-bikes and pedal bikes, which is a really interesting thing to look at in Santa Barbara. So we have a bit of data along these lines. We have also been putting out these mobile counters. So these are great because we put these tubes down and people ride their bikes over them, and you can get the direction of the bike and you get continuous data for however long you put the counter out. So often we'll put it out for 2 weeks and then you can get 24-hour data as opposed to just the manual counts. You know, as many students as we haven't found students that want to sit out there for 24 hours, and who can blame them? So it's just kind of different types of data. And then the third thing we've been doing is we've been working with the University of Davis, who are really skilled in modeling bike information, to try and understand, if we put a bunch of different data sets together, can we map high, medium, and low bike ridership for our whole city? So this is a representation of what the data looks like, where we've summarized it for hexagons. And you can see, you can get kind of a sense about where we have categorically different levels of ridership. And often for the kinds of decisions that we're making, we don't need to know if is it 10 or 15 riders. We just need to know, where do we have lots and where do we have little. So this is sort of a helpful snapshot of our whole city. The other thing, I'm so excited, so new, I don't even have a slide for you. One thing that's helpful for normalizing all the data is to have a few locations where you are always collecting bike data. And we just had these 2 cameras installed in Santa Barbara. One just got put in on State Street near Cabrillo, and it counts. It uses an image, and then it has an AI that pulls out what it sees. So it'll count cars, bikes, pedestrians, skateboards, and then it will also tell us if two things almost cross paths, so it'll pick up crashes and it'll pick up near misses. And so we'll have this data that'll be 24 hours a day. Every 15 minutes we'll have a number, and this is going to be transformative in terms of us answering questions. And I'm so excited we managed to accomplish that. Here's some of the examples of things we have discovered. So we've seen, overall, we're seeing an increase in the city of Santa Barbara in terms of the number of bikes that we have over time. We are seeing in Santa Maria a decline in bicycling that's happened over the years that we've been collecting data. We're seeing an increase in e-bike use, which I don't think will surprise any of us. I was surprised to see that over 50% of our bicycling in Santa Barbara is actually e-bicycling now. So this is, if you are thinking about how to make the world better, on what decisions need to be made, I'd say this is a hot topic in our community, is the e-bicycling, which we can talk about. This is just a little closer look at the map that we have that we're making with the University of Davis, and it really integrates very diverse data that we have into a model. So we're thinking about everything from how do we incorporate Strava data, safety data, measures of how connected our bicycling infrastructure is, weather data, etc., into these maps of annual levels of walking and bicycling. In the introduction, it was mentioned that I run a website called bikemaps.org. This is really designed to improve our data on bike safety. So it's estimated that only 20% of bike crashes are reported to an official source. So if a bike crashes with a car and the police are called, or there's an insurance claim made, then these get logged into some kind of official reporting. But most of the things that happen for bikes, either the cost of repair of the car or cost of repair of the bike, is small enough that people don't bother with this sort of thing. And so if you're trying to understand how to keep people safe and you only have 20% of unsafe incidents out there, it can make it really challenging to make good decisions. So in 2014, when I first became really interested in thinking about bike safety, I developed a website called bikemaps.org, and it works anywhere in the world. You feel like you're on Google Maps. You can just Google it at your leisure, and you can log in there a bike crash or a near miss that you've had and give us details about what happened. And then we use that for research, but we also give it to the city. So we work with the city of Santa Barbara in particular, and we hand them that data so they can see where incidents are changing. It's really important that we're thinking about safety in our region because we are seeing an increase in bike safety incidents per 100,000 people. So is this because we have more bikes than other places? That could be. Is it because we have more e-bikes than other places? That could be. But nobody really knows why we're seeing these trends. So we can develop lots of hypotheses, but I think we'd like to get down to testing those. With this is an image that's just going to run for you to show you this bike and pedestrian dashboard that we're about to release for the whole county of Santa Barbara. So this is a dashboard. During COVID, there were a lot of dashboards that helped us think about public safety. This is taking some of those same ideas to think about bike and pedestrian safety. So we're integrated the bike maps data, all the official reporting, and then allowed people to summarize it for different jurisdictions. So you might be interested in the whole county or a census tract or a city or a school district. You can look at different kinds of incidents. Maybe you're just interested in bikes, maybe you're interested in pedestrians. Gives you a lot of information right at your fingertips about what is going on in your own community. So you might be trying to be a decision maker, making better choices for your jurisdiction, or you might be an individual looking for the safest route. And either way, you will soon have access to this. Anyone will have access to this. And we will be adding additional data sets on bike volumes. We tried to add the bike volumes already, but the data is a bit spotty. And so it was too easy for people to misinterpret. So we're going to wait till we have a bit more data.
Sorry, can you say where that's going to be posted?
It will be available from the Spatial Center's website at UCSB. It will also be available on SBCAG's website. I will be aiming to put out, you can email me anytime and I will send you, I think it is already available. We just haven't made a link to it. So you could email me now and I can send it to you. We'll try and get some promotion of that happening so people broadly in the community know. The last bit about biking that I want to talk about. So we've talked about how we're counting the number of bikes, and we've talked about what we're doing to improve data on bike safety. But the other thing that's interesting is infrastructure. So where do you have bike lanes? Where do you have multi-use paths? What's happening with these things in Santa Barbara? It matters because you may have noticed an increase in construction of this kind of infrastructure in our city because our local government has been very good about attracting funding for these kind of projects. But if you have ever looked for a map of where's the best place to bike, you might have seen this map. This is a bike map from, you can get it from SBCAG. Trouble is, it was made in 2013, and things have changed a little since 2013. So we worked with SBCAG and partnered on a grant that went to Caltrans and was awarded. And through this grant, we are going to be developing an AI method for updating this data so we can have bike route data updated all the time. And the way it works is I'm currently in Canada, which is where I'm from, and I have much of my career was spent here. So I worked for many years on this project called the Canadian Bike Comfort Classification System. This is a map here of the city of Vancouver, and every segment of infrastructure is classified as to high, medium, or low comfort for a bicyclist. So what makes bicycling comfortable? It could be that the cars aren't rushing by you so quickly, that it's a low volume street, that you are separated from vehicles and you have a barrier between you and them. So rather than having like the coastal route or the Guadalupe route, which is the type of thing we have in our current bike map, what we want is to have every road segment and piece of infrastructure classified as high, medium, or low comfort so that if I'm trying to figure out how to get from my house to UCSB, I can look and say, what would be the most comfortable route for me to take? In order to do that, the first thing you need is to figure out in your community what do people think makes comfortable biking, what makes medium comfort biking, and what makes low comfort biking. So we took the Canadian version and we did, with SBK's help, we ran a bunch of focus groups with people from the county to say, what kind of things would you like to see classified as high, medium, and low comfort? So this is already done, and we've come up with, a system of looking at high comfort. And high comfort is really there's not a ton of stuff that falls into high comfort. It's our bike paths, our multi-use paths, and anything where you do have like a strong separation between cars and bikes. And these are like areas where I think we think of them as 8 to 80. You would let your 8-year-old ride on them and you would still be happy riding on them when you're 80. These medium comfort things, or you might have a buffered bike lane, you feel like you have some space. Cars aren't moving too quickly, there aren't too many cars. And then the low comfort are the places that, you're probably wanting to avoid on your bike. Once we have that comfort classification, we use something called OpenStreetMaps or OSM, which you may have heard of. And it's like a Google Maps, but it's open source. And so every single street segment has a bunch of tags associated with it. And we develop a training data set that allows us to classify those tags into high, medium, and low comfort. And once we have that training data set, that's really the AI model that we can continue to apply. So every year we can extract the labels from OSM, rerun our algorithm, and come up with a new comfort classification. So we'll never be 13 years out of date again. Woohoo! Right now we have students working on building this classification data set. So they look on Google Maps to see what's there. Then they look in OSM to see what the labels are, and they kind of make a match with 1,000 different sets of data that we'll use to train and test our data. We found that we can do this with 80% accuracy. So in Canada, what will probably happen is we'll run the model and then we'll have experts look at it and tweak a few of the spots where maybe things are a bit sticky. And then we'll have a new map that is digital, so we could use it in a GIS, but we're also working with SBCAG to print it so that people, when they're arriving to town or visiting and they want to know how to get around, they can also have a printed map. Everything in AI. So one of my big data science passions is thinking about data quality. If we have good data that go into our AI models, comes out as good, and if we have bad data, what comes out is bad. When you use something like OSM is actually very good because so many people have been contributing to it, but we can always make it better when we have local experts review what's there and update it. So one of the things we have done over the fall is we've hosted a mapathon where we've invited people to get in there and tidy up the data. This is ongoing. The more people that do it, the better. We have a person in town, Robert Rainwater, who's been doing this for many years in our community, so our data happens to be extra good. But we had over 1,800 people look at this and view the data in advance of us extracting it for the AI development. So I was really excited about that. So then just in summary, these are the 3 areas that felt important to me when I moved to Santa Barbara. One is what's happening with volumes. And so we are seeing increases, but it depends on the region. We are seeing an increase in e-bikes, so that's something to talk about. We have this new safety dashboard where you can find hotspots of unsafe bicycling. And you can also understand the trends in your region. And then we have this AI bike infrastructure map underway, which will be helpful, I think, to our community. How are we doing? So I could pause here for questions or I could keep going. Maybe I'll keep going just because the Zoom interface is a little easier that way, but I would love to talk more about bikes at the end. Okay, the next major topic I'm going to talk on is digital twins of nature. So if you perhaps worked in engineering, you may be most experienced with the idea of a digital twin, which is that you have some kind of digital representation of something that's real. So a plane would be a good example of something that often is digital twinned. So you could tweak something in the plane and understand what would happen if you actually tried to fly it without trying to fly it and crashing. Jack Dangermond, who owns the primary GIS company in the world, which is called Esri, it's where all the ArcMap and ArcGIS products come from. He gave the Nature Conservancy, him and his wife Laura, gave the Nature Conservancy a gift which allowed them to purchase Point Conception, which was the old Bixby Ranch. And they conserved a lot of land in doing that. But Jack was also interested in not just the conservation of the land, but how we could create a model that could be applied to other conservation areas where we had a highly instrumented landscape, which we could use effectively as a sandbox to understand if we made a bold decision on this land, what would the future look like? And so he has tasked UCSB Spatial Center with building the first digital twin of nature. Now, how one does this can be quite complicated because in a digital twin that is something that is human built, you might be able to get the detail down to every nut and bolt, but we can't map every blade of grass, nor do we think that is like a useful approach. So we have a challenge ahead of us in thinking about what would it look like to build this digital twin of the Dangermond Preserve. You know, some interesting things about it is it's over 24,000 acres in size with 8 miles of coast. It's home to over 600 species of plants and over 200 wildlife species. And so there's a lot of detail and a lot of interesting things that we could think about in terms of a digital twin. Some of the characteristics of this system that we know we want is a digital twin needs to be a combination of data. So this is, the GIS data that we map. It needs to include tools, perhaps for visualizing data or moving around and selecting different components. And it also needs models because a digital twin needs to be predictive. So you want to be able to say, if we make a change, what would that look like in the future? Or if we made a change to this part of the landscape, how would it affect some other part of the landscape or some other ecological system? The Point Conception Institute is also a research it's a research body. And so one of the common issues with sort of nature preserves as research institutes is that each researcher goes there, does the research, and then leaves with all of their good data, all of their smart insights. And so a digital twin needs to be a living entity where people who are doing work put the information back in, and then new things can come out. So it needs to have both support output for making decisions as well as ways of inputting data by the user community. Theoretically, there's a lot I can think about in a conceptual space around the digital twin, but this is one of those projects where the devil is definitely in the details. There's so much data. So you have imagery data. This could be satellite imagery. It can be drone data. We have researcher data. Contractor data, there's fences and wells and things that need to be maintained, lots of data on species. There's a number of real-time sensors. We have historical data, we have mobile data, we have sensors on animals, we've got sensors in the phones of all the people that are doing the work on the landscape. So how do you put all that data together into something that is useful? So our first effort and where we are right now is the data were everywhere in all kinds of formats and all kinds of places. And so we've created kind of the back end for a digital twin, which we think of as a research bench for scientists working at the preserve. So if you think if you were a chemist, perhaps you would have had a fume hood and some, other instruments that you would use as you did your work. As data scientists, we need a research bench as well. This needs to be kind of a place that houses all of our data in a way that can be easily shared and served. So there's over 50 data streams that we have figured out how to put into this, and you can analyze all kinds of things. This is some camera trap data. So they put up cameras, and when a motion happens, there's a picture taken. And then you can see different animals at different locations along the preserve. This is really interesting data, but it doesn't get used that much because if you just have a pile of images, obviously that's a lot harder to use than if you have points on a map that tell you how many of each species were observed at that location. It's much more usable. Here's an example of some fire data that we have. So you can see fires through time. What's the historical history of fire in the area? That can be really important data for a variety of different vegetation questions that you might want to ask. Remote sensing data is, Also a huge part of what we have. These can be things that change in time. These are well sensors that are measuring different kinds of water. Really cool and also hard for us to figure out how to handle at first were drone imagery. So different researchers will go out there and fly drones to collect data for particular projects. And you really want that data to be available to everyone. So this is an example of the drone data. And how to get that all into a system that was easily used was quite challenging. We're not quite done, but we're almost there. One of my favorite features is you can put your data sets into a cart just like you're shopping on Amazon, and then download all of those and take them and work on a project of your own choosing. So we think this will really accelerate the use of the data at the Dangermond Preserve by a lot of different students and professors. Here's some LiDAR data. So this is laser scanning data that allows us to look at the preserve in 3D. You can imagine our future digital twin may have some video game-like features, and this will be a very important component of being able to serve data to people in a more virtual reality context. Right now, we are really thinking a lot about what's happening here? I don't think I need that. Sorry. Right now, we've been working a lot on building the back end of the digital twin, but the future of the digital twin will have more modeling components available to us. And we have a grad student right now whose project is working on thinking about what are sort of foundational models that we can use to improve the modeling at the Dangermond Preserve. One of the things I think we're going to work on is trying to use the Dangermond Preserve as a model of carbon sequestration. So we could look at if we plant different things, if we move things in different places, if fire changes, what would that look like in terms of the carbon sequestration of this landscape? We also want to think about how this digital twin could be used in other preserves. What are the components that are really special to here because you need particular kinds of data versus what could be transported to other places? Okay, so those are the two sort of big science projects we are working on. What is happening here? Is that looking better again to you all?
Yes.
Probably.
Yeah.
Okay, great, thank you. As I mentioned, in the 1990s, when the field of GI science was established, one of the things that Mike Goodchild and his colleagues did was developed an initial curriculum for the field of GIS. And what it was a set of concepts and how you would teach these concepts in a big binder. And the binder would get copied and then it would go out to people, and all over the world, people used this binder to teach GIS in the early days. And it turned out to be a very important part of establishing a brand new field because people could have agreed upon concepts that were easy for them to teach in a consistent way. Jack Dangermond funded that initial work. And he came to, well, unfortunately, we took a bunch of students to Redlands, where the headquarters of Esri is, and Jack had 6 minutes to meet with us. And I said, Jack, is there anything we can do for you? And he said, yes. You could make us a modern curriculum for GI science. So then I learned I should never ask Jack Dangermond if there's anything I can do for him because he gives me very difficult jobs. And so he asked us if this was the charge that he gave to us. And while it is a challenging job, I think it is a very important job because you can imagine how the field of map data science is exploding. It just has so many applications because we have so much data. And there are some aspects of it that I think if we teach properly can be so impactful. So we are in the process, it's a group of faculty who are leading really the whole discipline in developing this new curriculum, which we call the Guide to the Geographic Approach. And we have a website that you can just Google, Guide to the Geographic Approach will come up. And our challenge is in a time where technology changes so quickly, where everything's happening in the cloud, where ethical considerations of what we're doing with digital data matter a lot, and where we have really important questions to answer. How can we develop a curriculum that anyone in the world can use in a way that works for them? So our curriculum has, I'd say, three components. And the first is that it's centered around an applied problem. The biggest frustration that I have is when I'm working with spatial data science students or just data science students, and they show me something that they've done, and I ask them what it means, and they cannot tell me. They'll just say, well, this algorithm looks a bit better than that algorithm. The R squared is a bit better. This is not helpful information. What we want to teach students to do is to ask questions that matter and then do analysis to answer that question in a way that they can then describe. So this focus on applied problem solving, it could not be more important to me or more integral to the work of the Spatial Center. The second thing is that historically in data science, ethics is taught as sort of an afterthought. And rather than tacking it on at the end, we are trying to infuse it into everything we do. Because good data science should be ethical data science. And a lot of what is ethical involves who's involved. It also involves what are the qualities of our data, what are the questions that we're asking. So we're working hard to incorporate ethics. And then we really want it to be focused on kind of a shared set of competencies. So you will know when you're done. When do you have enough knowledge that you can be, we can unleash you on the world in a safe way as a student? These are the modules that we've developed so far. So we pick a problem that is that allows us to develop a workflow that is quite useful and has many applications in GI science. So understanding disease outbreaks, it is all about understanding how to map a hotspot. How do you look at differences in spatial patterns, etc. And then we teach techniques, ethical lessons, and labs associated with this. And instructors can take our whole module, or maybe they just like the videos that we've made, or maybe they just like the practical lab that we've made. They can also just use the bits that work for them. So it's very much considered an open source project where we hope people will make it their own. So far, it's being used in 35 different universities globally, or not just universities, in organizations globally. We've had close to 15,000 views of the site, and we're seeing an increase in the number of downloads of the material. You don't have to download the material to use it because it's all in the cloud. They could just be viewing it and using it in that way. But yeah, we're seeing that there's a lot of interest, and there's especially a lot of interest in how do you teach AI methods in this space. So even from 2 years ago when we started it to now, the demand for AI tools has really increased, and it sort of is a reminder of the importance of doing this kind of work iteratively. Okay, the last thing I just wanted to quickly share, when I was interviewing for my job, one of the things that kept coming up was when there were the fires and mudslides, UCSB didn't have resources to respond, even though they had the expertise to help with mapping in an emergency situation, with deploying resources, with optimizing evacuation routes. There wasn't kind of an organization that was prepared to quickly deploy in this kind of setting. And so partly in response to that, I'm really interested in developing the GIS Earth Observing Service Center, which is kind of like, you could think of it as a hybrid between a training center, a consultant center, and a research center that has a few staff members. It employs students to work on local problems, but it also can partner with anyone within the university or anyone outside the university. And we're hoping in this way to get a few more resources that are ready to deploy quickly in emergencies, as well as more of these kind of technologies and services into our community. Because UCSB is the place where these ideas were founded, I really want our community to also benefit from having access to these things. So we have developed this center, and we offer a number of different services. We can do field data collection, data cleaning and modeling. We build a lot of dashboards. And there's kind of a low-cost way that people can work with us to have some of this work done, either in their organization, their nonprofit, or they're promoting a lot over the next little while. And if you can think of someone or some organization that should know about this, I would love to hear from you on that. Okay, that's it. You can contact us anytime. I'm sorry I'm not there to eat my lunch with you or have a cup of tea, but I would also love to do that. I'll be back soon. And this isn't just my work. There's a large group of people working on it, even beyond this. This is really the group that works on the bike stuff. Lizzie Shaddle is the manager of our new Geo Center. So if you want to talk about that, we'll connect with her. But we're just have such a great group. So I'm very thankful to have been here. And that is all.
Did you go back one screen so I can see the rest again?
Oh, yes. Can I go back one screen? Hold on. Hmm. 1 second. I can, and I will. Is this the one you'd like?
Yes, thank you.
I see Robert was quick to get his hand up here.
Thank you. This was wonderful. I've been involved in sustainable transportation advocacy since I was a student, and I this is the first I knew of you or this research, so I'm not quite clear how there's such a disconnect. Um, how I'd really love to meet with you if that's
Mhm.
possible. Um, but yeah, who do you work with locally? Do you work with what used to be the Bicycle Coalition,
Mhm.
the county and city governments? Yeah, tell me something.
Yeah, I'm sad we haven't connected yet. I give a community presentation every year on what we're doing on biking. I work with the city of Santa Barbara. Jessica Grant is one of my main contacts there, and Sam Firstner, who has left for MDT. We work with SBCAG a lot. We also work with Move Santa Barbara County, who's the bike advocacy organization. So usually they send out our information through their listservs, etc. But it's, always a challenge to reach all the interested people. So we will make sure if you email me, I'll make sure you get on the list for all the bike communication that we do because we do a fair amount.
Well, thanks. Yeah, it's funny you showed that county bike map. So I worked on the very original one about 30 years ago
Wow.
in the 1990s. And the way we did it was we just laid out a regular map on the floor and just got a bunch of us to just start with markers and say, oh, yeah, this is how I go, and so on. Um, and what's interesting is that that's basically how it was for decades. And that actually worked pretty well because you have people who actually ride and so on. I mean, one thing I thought was interesting, you talked about comfort levels, and that gets complicated because people may find something more comfortable, but actually is less safe.
Mhm.
What do you do about those cases?
Mhm. That is true. So one of the very so we incorporate research evidence into our comfort mapping. So some of it is based on statistically what we know leads to safer conditions for bicycling, and some of it is based on what people feel. Like my favorite one to talk about from this perspective is people think it's very safe to ride on a multi-use path like our beachfront. The data shows that these aren't the safest places to ride because when you mix bikers and walkers and dog walkers and fast bikes and slow bikes, it's not a great situation. You need space for each mode of transportation, and even a e-bike is not really the same mode as a pedal bike. So, yeah, we do try and incorporate evidence that what the evidence says also in our analysis.
Chris, it's Craig Prater. I wanted to ask about the AI that you were using for the classification of the bike lane comfort levels. So you mentioned something about tags in the mapping data. Can you talk more about what those tags are?
Yeah, I'm going to bring up an example. example. So for example, here's South Miller Street. And if you go into OpenStreetMap and look at what is the tag, the relevant tags associated with it, it'll say cycleway equals lane. And that means that somebody went in there and identified that there is this bike lane happening there. Whereas this part of this multi-use trail will have these different tags. Highway equals cycleway, bicycle is designated, pedestrian is designated. So we pull that information out and we figure out what are the relationships between our high, medium, and low comfort and what those words say. And it can be a little bit complicated because OSM doesn't have a standard. It doesn't say that every time you have this particular infrastructure, you have to call it this particular thing. So some people might say cycleway, some people might say bike lane, some people might say bike preferred. So you have to figure out what all that language is and make sure that you can classify it.
Did you determine that text-based labels were a better approach than doing some sort of image analysis to actually see that there's a bike lane or something divided, et cetera?
Yeah, it's a lot. It would be a huge lift to do the image analysis. I suspect that in a future world, that is how we will do it. But right now, the amount of processing that would be needed it would take us years to do that at such a local scale. So this works quite well and is much faster.
Thank you.
Yeah, hi. Great presentation, and as a enthusiastic cyclist, I applaud all your efforts towards helping to create a safer infrastructure. Yesterday on Sunday, I was riding up Gibraltar Road and going uphill. I was passed by a jogger, and that's how fast I am on the bike. And I was wondering, is there a way for people, because all these people, I have my Huawei smartwatch, is there a way of integrating individuals, let's say fitness software and these findings, because this is doing a GPS recording of my bike ride. Is there a way of contributing that kind of data into making a more comprehensive map?
Yes, you bet there is. So the main data source we use around this is Strava data. So our team has done a ton of work, probably the most in the world, on what does Strava mean in terms of representing all bicyclists. So we don't want to make maps or planning decisions that are only recreational riders who are the most comfortable, have the most access, will ride anywhere, they are bold. We want to make sure that we are making this data represent everyone. So it turns out that in a city, you can build a relationship between Strava riders and all riders. So if you are mapping on Gibraltar, almost every single person riding up there is using Strava. If you are mapping in a residential neighborhood where families are trying to get their kids to school, maybe 1 in every 50 riders are using Strava. So we actually have been able to use geography to build relationships between training data sets, which shows how many total bicyclists are there and the number of Strava riders that are there. I'm very passionate about this particular project. We could infuse other kinds of data. It's just that it can be hard to figure out how to access your individual data sets. It took us a long time to build that relationship with Strava. So we could build one with Garmin, we could use other ones. But Strava also captures so many riders that I think it's a pretty good one for us to work with.
Great, thank you.
David?
Yeah, another question if no one else. Going to the digital twin, dealing with the point conception land use. UCSB for many years was one of the pioneering centers for remote sensing data from satellites.
We still are.
And is that data actually in terms of tracking longitudinally changes in big tracts of land like that? Is that old remote sensing data, is it still being able to be incorporated in some of these longitudinal studies.
Yeah, absolutely it is. I think that's like one of our challenges is because we have so much data and we're trying to store it in the cloud so that everybody can access it anywhere. How far back do we go and make it available to everyone? We're starting with the kind of recent data, but we have like Amy Fraser, so I'm the Dangermond Chair in Geography. When that land was endowed and given to the Nature Conservancy, Jack and Laura also made a new position, a new endowed chair at UCSB called the Dangermond Chair in Conservation. This is held by my amazing colleague. Her name is Amy Fraser, and she is a remote sensor and brings that expertise to the field. And we do use, legacy satellite data in the analysis that we do, but also the integration of the drone data and the LiDAR data is also, I think, part of that remote sensing lens that the project has. But I love your knowledge of our department. That makes me so happy that people know about this.
On screen. I had a couple of things I wanted to comment upon.
Yeah.
I recently saw an email from the Nature Conservancy relating to the Dangermond Preserve saying that it was now open.
Really? Well, it's not open in my knowledge, which may be incomplete, is that it's not open to the public, but they have built some facilities there to make it a little more manageable to host researchers there. So I don't know what it means in terms of open. One of the reasons it's been so important for us to build these digital assets is for conservation reasons. They're cautious about who they let onto the preserve. Even I think I've been there twice in all the years I've worked there because they don't want us trampling around unnecessarily. So we're trying to give people the experience of being there to know what's there and know why it's special without actually heading out onto the landscape. So I don't think it's open.
Okay, there's an email that came in the last few days. There were a couple, 3 days I didn't check my email, but it came in the last few days, and it said it was open certain roads. It would lead to the coast. Now, I think perhaps it means one has to sign up and go with a group. I don't know. I can't remember exactly.
Yeah, I'm not sure.
I can certainly forward that information to you in terms of what he said, but it came from the Nature Conservancy itself. So that was one thing I was going to comment on. The other thing that I find would be extremely useful is your mapping that is real in any given time in case of a disaster like wildfire, because we in Santa Barbara often live in places where there is one exit onto a major highway, and we're going to have to know how the hell do we get out of X, Y, or Z.
Right.
So I can see that this kind of thing would be extremely helpful if you worked hand in hand with the fire department or whomever else under those circumstances.
Yes. So there is a group within the Spatial Center led by Professor Alan Murray. It's called the Wildfire Research Initiative, and they work with local fire departments and other fire-related agencies to do all kinds of mapping around these kinds of topics. This would be actually, if you're interested, I can put you in touch with that group to have a talk on this topic. It's all funded by Yardi. They've given
I'm sorry,
by Yardi, the company.
Yardi, thank you.
They funded, I think, over $5 or $6 million on this project to build. They do kind of fire evacuation. They look at shocking. This to me was so simple but so shocking. They mapped where all the fire hydrants were, and then how far. I put a buffer around each fire hydrant, and then you can see where there are spots in our region that the fire hydrants wouldn't reach. It was shocking to me that no one had already done this, but they do things like that. They also do drone projects where they can fly over a house and then do sort of mapping to show you where your vegetation needs to be pulled back from the house in order to keep it fire safe. So they're working on all kinds of things, and that could be a very interesting topic.
Okay, thank you. I think this has been a very fascinating talk, son, and I thank you very much for speaking to us. I think there are many here in this room and on screen that will end up contacting you.
Wonderful. I would love it.
And we're very, very pleased to have had you.
Thank you
last
so much.
questions?
Thank
So,
you.